If, as has been estimated, the world population doubles by the end of the century, it will require another 500 ammonia factories in order to make the fertilizer which will allow us to double cereal production. This in turn will require vast quantities of fast disappearing fossil fuels such as gas and coal. Clearly, it's time for another revolution. And this revolution may be brought about by plants such as this humble pea, which is a member of a family called the legumes, which also contains beans, clover, and alfalfa. This pea plant is being grown in very nitrogen-deficient soil. Nevertheless, it is a healthy and vigorous plant. This oilseed rape, being grown in exactly the same soil, shows all the symptoms of nitrogen deficiency: stunted growth and discolored leaves. What's the difference? Well, the difference is that the pea plant on its roots has these tiny pink nodules. You just about see them. They're really rather pretty color. And it's these nodules which appear to give the plant the ability to fix nitrogen from the air. Actually, this is not quite true. In fact, the nodules are guest houses for colonies of a bacterium called rhizobium, which starts life in the soil. This is a greatly magnified electron microscope picture of a root hair of a pea. The spots on the surface are clumps of rhizobium. They penetrate the wall of the hair and go down it, into the body of the root, where they multiply rapidly. The bacteria have the ability to combine hydrogen with nitrogen from the air to make ammonia, which is used by the plant instead of nitrate. In return, the plant supplies the bacteria with sugars as a food source. At the nitrogen fixation unit of Sussex University, they have been studying rhizobium's secret weapon, an organic catalyst called nitrogenase, which can unite nitrogen and hydrogen without any of the huge temperatures and pressures needed in the Haber-Bosch process. Lately, they have been able to isolate the genes for nitrogen fixation and to move them around from one bacterium to another. Genetic engineering of this kind is still in its infancy. But would it be too fanciful to imagine that one day we may have wheat with nodules on its roots or able to fix nitrogen in the way the bacterium does? The hungry peoples of the world need some completely new solution. And it's biological processes which already fix 500 million tons of gaseous nitrogen per year, which could prove to be their salvation.